Hello, Geometry Land. What we're going to do today is work with parallel and perpendicular lines. Yeah. So let's learn some theorems about those. Our first theorem is Theorem 3.7, which means it has no name. It's Chapter 3. It's the seventh theorem. That's all that means. So, Theorem 3.7. If two lines are parallel to the same line, then they are parallel to each other. So if A is parallel to B and B is parallel to C, then A is parallel to C. So it's just kind of like our law of syllogism and like our transitive property. So you can go from A to B and you can go from B to C. So then you know that you can go from A to C. So you can do that with parallel. Doop-de-doop. My clicker's not working. There we go. Next slide. Theorem 3.8. So again, chapter 3. This is our 8th theorem. And it says, in a plane, if two lines are perpendicular to the same line, then they are parallel to each other. So let's break down what that means. So M and T are perpendicular. Right there. We got our right angle. Also, N is perpendicular to T. Right there. We have a right angle. So as long as I have this right angle here and this right angle here, that lets me know that I have congruent corresponding angles right here. I have two right angles. Then my lines are parallel. So this is very similar to your corresponding angles postulate converse, except now it's dealing with using your perpendicular lines, knowing that these have to be 90-degree angles. And Theorem 3.9 has a name. It's called our perpendicular transversal theorem. And it says this: in a plane, if a line is perpendicular to one of two parallel lines, then it is also perpendicular to the other. And let's look at what this is saying. If N is perpendicular to L, so what that means is right here we've got N perpendicular to L, and L is parallel to M, then we know we also have to have another right angle here, making N perpendicular to M. So let's do a proof with all of this goodness in one big old proof. Alright, let's start with our statements. S-T-A-T-E-M-E-N-T-S. Statements. Crooked line. Reasons. So, statements, again, are the things we know. Reasons are how we know them. Let's see what we've got. We've got that line C is perpendicular to line B. And we have that line B is perpendicular to line D. And we also have that line D is perpendicular to line A. That's given to us. Alright, all information there is given. So let's see what we can do here. Alright, well, since we know that C is perpendicular to B and B is perpendicular to D, that lets us know that C and D are parallel to each other. Does that make sense? Yeah? Okay. Well, also, since B is perpendicular to D, so B is perpendicular to D, and D is perpendicular to A, that also lets us know that B and A are parallel. And that's actually, I think, the path I want to take. I know that B is parallel to A. And this was one of our theorems that didn't have a name, so you kind of just have to write it out in words, which said if two lines are perpendicular to the same line, which in this case they are, D is both perpendicular to B and A, then the two lines are parallel. So I know that line B and line A are parallel. Well, let's go back and try and combine basically this statement here with this statement here. And I'm going to go back, take a trip down memory lane, and go back to my perpendicular transversal theorem, which said if line N is perpendicular to line L and line L is parallel to line M, I know that line N is perpendicular to line M. I'm going to apply all of that here. I know that C is perpendicular to B. And I know that B is parallel to A. So what that means is if I continued C out, C would then be perpendicular to A. And that one had a name, so I can use its name. That was our perpendicular transversal theorem. Theorem. There we go. Now, that may have seemed confusing, all right, but we will be working with proofs the rest of the, the 9 weeks and into the next 9 weeks, so we'll have some time to practice this stuff in class too. Now, let's look at our last question. A carpenter plans to install molding on the sides and the top of a doorway. The carpenter cuts the ends of the top piece and one end of each of the side pieces at 45-degree angles as shown. Will the side pieces of molding be parallel? And explain this. So what we need to do is let's just put all of our molding together and see what happens, okay? If we put our molding together this way, we have a 45 and a 45, which makes a 90, and a 45 and a 45 this way, which also makes a 90. So if you look at this as one angle, that's 90 degrees, and this is 90 degrees. Well, we can go back to this theorem that says if we have two lines perpendicular to the same line, then our lines are parallel. Well, if you go back to this picture, you have that this line right here is perpendicular and this line right here is perpendicular all to the same line here, which lets me know that this side will be parallel to this side. So, will the side pieces of molding be parallel? Yes, they will. And so to explain that, you can just say that the two sides are both perpendicular to the top, so the two sides will be parallel. Have a good one.